When we are looking at a linear function rule written in the form f of x equals mx plus k, that plus k parameter will be shifting the graph of the function vertically, up and down. On this toolkit, we have our parent function pictured first, f of x equals x. Again, our simplest graph, our simplest function rule, start value of 0, slope of 1, right there. G of x equal to x plus 3 is going to shift the graph up. When we have a plus k, we are going to be shifting the graph up. So here is my graph of g of x equal to x plus 3. I don't need to count anything. I just see of my two options, plus 3 and minus 4. This one represents a vertical shift of the parent function. But to look at that more precisely, I could see that for each value of x, the output, f of x, actually g of x, is 3 greater than it was for the parent function. So up 3. When we are looking at g of x equal to x minus 4, that will be a shift of the graph down. Oops. A shift of the graph down. So when we are subtracting a value of x, that says down. And this is my graph of, wow, g of x equal to x minus 4. Again, of the two options, this is going to be easily matched to x plus 3 because I am going up, and this is going to be easily matched to g of x equals x minus 4. But I could also count that for each value of x, my output g of x is down, subtracting 4, minus 4, 1, 2, 3, 4. This remains true if my value of m, if my slope, my m parameter is negative. So let's compare j of x equal to negative 2x, which is going to go through the origin, steeper than the parent function, steeper than the graph also of f of x equal to negative x. And then, let's see, k of x equal to negative 2x plus 5 is going to go up. So here is my graph of k of x equal to negative 2x plus 5. I can use what I learned in my linear unit to see, yes, this has a y-intercept of 5, but that's really not what I'm focusing on here. I'm focusing on a shift up of 5. So I would be able to identify this graph even without those numbers. When I'm looking at L of x equal to negative 2x minus 5, that will represent a vertical shift down. So again, I can see that the y-intercept is negative 5, but even without that negative 5 here, of these three options, I would be able to identify L of x because it is the graph that is shifting down from negative 2x. So I should have highlighted this one. As we have talked about before, Desmos is a great way to practice and cement your understanding of the effect of a change in k. So here's my parent function, f of x equals x, and I can play around with shifting that up by 1, by 3, by 7, or shifting the graph down by 2, down by 6. This also works if I'm looking at a slope that's not 1. So here's 2x plus 1, shifting up, 2x plus 7, shifting it up even more, subtracting it down, vertical shift down. And this also, the effect of k, remains the same when my m is negative. So if I go up, if I add a value for k, I'm shifting the graph up. If I'm subtracting, or if my value of k is negative, then that represents a vertical shift down.